Process Technology. Unit 10. Basic Laboratory Glassware and Equipment. Outline. Laboratory glassware and equipment. Personal protective equipment. Laboratory glassware and equipment. In the process industry, laboratories manage the testing of chemicals, crude oil, gases and fuels, petrochemicals, and a variety of other products and materials. Laboratory glassware. Laboratory glassware is a variety of equipment used in scientific work, and traditionally made of glass. Each piece of laboratory glassware has a name and a purpose. Laboratory glassware is special. It needs to resist chemical attack. Some glassware has to withstand sterilization. Some glassware is used to measure specific volumes, so it should not change its size appreciably over room temperatures. Chemicals may be heated and cooled so the glass needs to resist shattering from thermal shock. Beaker. No lab would be complete without beakers. Beakers are used for routine measuring and mixing in the lab. They are used to measure volumes to within 10% accuracy. The flat bottom and spout allow a beaker to be stable on the lab bench or hot plate. Plus it's easy to pour a liquid without making a mess. Beakers are also easy to clean. Beakers are commonly made of glass, usually borosilicate glass, but can also be in metal, such as stainless steel or aluminum, or certain plastics. Beaker tongs are used to pick up beakers. Flask. Flasks come in a variety of shapes and sizes, but a common distinguishing aspect in their shapes is a wider vessel body, and one, or sometimes more, narrower tubular sections at the top called necks which have an opening at the top. Laboratory flask sizes are specified by the volume they can hold, typically in metric units such as milliliters or liters. Laboratory flasks have traditionally been made of glass, but can also be made of plastic. Flasks can be used for making solutions, for holding, collecting, measuring chemicals, samples, solutions, etc. For analysis, for chemical reactions or other processes such as mixing, heating, cooling, boiling. There are several types of laboratory flasks, which have different functions within the laboratory. Round bottom flask. A round bottom flask is a flask with a spherical bottom. These flasks are accompanied by the necks, at the ends of which ground glass joints are mounted to quickly and tightly connect to the apparatus, a reflux condenser or dropping funnel, etc. The round bottom flask is usually made of thick glass and can tolerate large pressure and temperature differences, that allows carrying out the reactions under pressure and vacuum, as well as high-temperature reactions and boiling. Some varieties of the round bottom flasks are Multiple neck flask. Schlenk flask. Multiple neck flasks have 2 to 5, or even 6 necks, each topped by ground glass connections. Multiple neck flasks are used in more complex reactions that require the controlled mixing of multiple reagents. Schlenk flask is a flask with a ground glass opening and a hose outlet and a vacuum stopcock. The tap makes it easy to connect the flask to a vacuum nitrogen line through the hose and to facilitate the reaction either in vacuum or in an atmosphere of nitrogen. Schlenk flasks, like most laboratory glassware, are made of borosilicate glass. Distillation flask. Distillation is one of the most widely used methods to separate mixtures of different substances. Distillation flasks are intended to contain mixtures that are subject to distillation, and to receive the products of distillation. Similar to the reaction flasks, the distillation flasks usually have only one narrow neck and a ground glass joint. Distillation flasks are made of thinner glass than the reaction flasks, so that they are easier to heat. Distillation flasks are available in various shapes. They are sometimes spherical, test tube-shaped or pear-shaped, also known as Kjedal flasks. Reagent flask. Reagent flasks are usually flat-bottomed flasks, which can thus be conveniently placed on the table or in a cabinet. Certain types of flasks are supplied with a ground glass stopper in them, and others that have threaded necks close with an appropriate nut or automatic dispenser. Florence flask. The flasks are often long neck. Sometimes they have the incision on the neck, which precisely defines the volume of flask. They can be used in distillation, or in the heating a product. Flasks with flat bottom. These flasks cannot withstand too much pressure or temperature differences due to the stresses which arise in a flat bottom. These flasks are usually made of weaker glass than reaction flasks. Erlenmeyer flask. An Erlenmeyer flask, also known as a conical flask or a titration flask, is a type of laboratory flask which features a flat bottom, a conical body, and a cylindrical neck. The slanted sides and narrow neck of this flask allow the contents of the flask to be mixed by swirling, without risk of spillage, making it suitable for titration by placing it under the burette and adding solvent and the indicator in the flask. Such features similarly make the flask suitable for boiling liquids. The narrow neck of the Erlenmeyer flask can also support filter funnels. The Erlenmeyer flasks are especially appropriate for recrystallization. Like beakers, Erlenmeyer flasks are not normally suitable for accurate volumetric measurements. Their volumes are approximate within about 5% accuracy. Volumetric flask. A volumetric flask, measuring flask or graduated flask, is a laboratory flask, calibrated to contain a precise volume at a certain temperature. Volumetric flasks are used for precise dilutions and preparation of standard solutions. These flasks are usually pear-shaped, with a flat bottom, and made of glass or plastic. The opening of the flask is either furnished with a plastic snap, screw cap or fitted with a joint to accommodate a polytetrafluoroethylene or glass stopper. The neck of the volumetric flask is elongated and narrow with an etched ring graduation markings. The marking indicates the volume of liquid contained when filled up to that point. Vacuum flask. A vacuum flask, also known as a Dewar flask, Dewar bottle or thermos, is an insulating storage vessel that greatly lengthens the time over which its contents remain hotter or cooler than the flask's surroundings. The vacuum flask consists of two flasks, placed one within the other and joined at the neck. The gap between the two flasks is partially evacuated of air, creating a near vacuum which significantly reduces heat transfer by conduction or convection. In laboratories and industry, vacuum flasks are often used to hold liquefied gases, often liquid nitrogen, for flash freezing, sample preparation and other processes where maintaining an extreme low temperature is desired. Larger vacuum flasks store liquids that become gaseous at well below ambient temperature, such as oxygen and nitrogen. Buchner flask. A Buchner flask, also known as a filter flask, suction flask, sidearm flask, Kitasato flask or Bunsen flask, is a thick-walled Erlenmeyer flask with a short glass tube and hose barb protruding about an inch from its neck. The short tube and hose barb effectively act as an adapter over which the end of a thick-walled flexible hose tubing can be fitted to form a connection to the flask. The other end of the hose can be connected to source of vacuum such as an aspirator or vacuum pump. Preferably this is done through a trap, which is designed to prevent the sucking back of water from the aspirator into the Buchner flask. The thick walls of the Buchner flask provides it the strength to withstand the pressure difference while holding a vacuum inside. It is primarily used together with a Buchner funnel fitted through a drilled rubber bung or an elastomer adapter, a Buchner ring, at the neck on top of the flask for the filtration of samples. The Buchner funnel holds the sample isolated from the suction by a layer of filter paper. During filtration, the filtrate enters and is held by the flask while the residue remains on the filter paper in the funnel. Graduated cylinder. A graduated cylinder, also known as measuring cylinder or mixing cylinder, is a common piece of laboratory equipment used to measure the volume of a liquid. It has a narrow cylindrical shape. Each marked line on the graduated cylinder represents the amount of liquid that has been measured. Bottles and jars. Bottles are containers with narrow openings generally used to store reagents or samples. Small bottles are called vials. Vials can be used as scientific sample vessels. For instance, in auto-samplers in analytical chromatography. Jars are cylindrical containers with wide openings that may be sealed. Bell jars are used to contain vacuum. Test tube. Test tubes intended for general chemical work are usually made of glass, for its relative resistance to heat. Test tubes made of expansion-resistant glass, mostly borosilicate glass or fused quartz, can withstand high temperatures up to several hundred degrees Celsius. A chemistry test tube typically has a flat bottom, a round bottom, or a conical bottom. Some test tubes are made to accept a ground glass stopper or a screw cap. Test tubes are widely used by chemists to handle chemicals, especially for qualitative experiments and assays. Their spherical bottom and vertical sides reduce mass loss when pouring, make them easier to wash out, and allow convenient monitoring of the contents. The long, narrow neck of test tubes slows down the spreading of gases to the environment. Test tubes are convenient containers for heating small amounts of liquids or solids with a Bunsen burner or alcohol burner. The test tube is usually held by its neck with a clamp or tongs. By tilting the test tube, the bottom can be heated to hundreds of degrees in the flame, while the neck remains relatively cool, allowing vapors to condense on its walls. Test tube clamp is used to hold a test tube, particularly when hot. Test tube rack is used to hold several test tubes at one time. Burette. A burette is a graduated glass tube with a tap at one end, for delivering certain volumes of a liquid, especially in titration. It is a long, graduated glass tube, with a stopcock at its lower end and a tapered capillary tube at the stopcock's outlet. The flow of liquid from the tube to the burette tip is controlled by the stopcock valve. There are two main types of burette. The volumetric burette. The piston burette or digital burette. A volumetric burette delivers measured volumes of liquid. Piston burettes are similar to syringes, but with a precision bore and a plunger. Piston burettes may be manually operated or may be motorized. Pipette. A pipette is a laboratory tool commonly used in chemistry to transport a measured volume of liquid, often as a media dispenser. Pipettes come in several designs for various purposes with differing levels of accuracy, from single-piece glass pipettes to more complex adjustable or electronic pipettes. Glass rod. A glass rod, glass stirring rod or stir rod is a piece of laboratory equipment used to mix chemicals. They are usually made of solid glass, about the thickness and slightly longer than a drinking straw, with rounded ends. Stir rods are generally made of borosilicate glass or polypropylene plastic. They are usually between 10 and 40 cm in length and about half a centimeter in diameter. A stirring rod is used for mixing liquids, or solids and liquids. Stir rods are used as part of a laboratory technique when decanting supernatants. The contact helps to negate the adhesion between the side of the glassware and the supernatant. The stir rod is responsible for the liquid running down the side. Using a stir rod also grants more control over the rate of flow, which is important in cases where chemicals may react violently. This process is also used to pour a liquid from a large-mouthed flask or a beaker into a test tube. Glass rods can also be used to induce crystallization in a recrystallization procedure, when they are used to scratch the inside surface of a test tube or a beaker. They can also be used to break up an emulsion during the separation. Laboratory condenser. In chemistry, a condenser is a laboratory apparatus used to condense vapors, that is, turn them into liquids, by cooling them down. Many different types of condensers have been developed for different applications and processing volumes. The simplest condenser is just a long tube through which the vapors are directed, with the outside air providing the cooling. More commonly, a condenser has a separate tube or outer chamber through which water, or some other fluid, is circulated, to provide a more effective cooling. Condensers are routinely used in laboratory operations such as distillation, reflux, and extraction. Laboratory condensers are usually made of glass for chemical resistance, for ease of cleaning, and to allow visual monitoring of the operation. Specifically, borosilicate glass to resist thermal shock and uneven heating by the condensing vapor. Desiccator. A desiccator is a sealable enclosure containing desiccants used for preserving moisture-sensitive items. A common use for desiccators is to protect chemicals which are hygroscopic or which react with water from humidity. Desiccators are sometimes used to remove traces of water from an almost dry sample. In laboratory use, the most common desiccators are circular and made of heavy glass. There is usually a removable platform on which the items to be stored are placed. The desiccant, usually an otherwise inert solid such as silica gel, fills the space under the platform. Separating funnel. A separating funnel, also known as a separation funnel, separatory funnel, is a piece of laboratory glassware used in liquid-liquid extraction to separate the components of a mixture into two immiscible phases of different densities. A separating funnel takes the shape of a cone with a hemispherical end. It has a stopper at the top and stopcock at the bottom. Separating funnels used in laboratories are typically made of borosilicate glass and their stopcocks are made from glass or polytetrafluoroethylene. Tile tube. The Tile tube, is a laboratory glassware designed to contain and heat an oil bath. The apparatus itself is a glass test tube with an attached handle, which provides a means of introducing a fluid, such as a gas or a liquid, into the interior of the tube. The arm side or handle is not to grab it over there but to supply heat. This heat moves uniformly in a circular manner throughout the tube. Such a setup is commonly used in the determination of the melting point or boiling point of a substance. Evaporating dish. An evaporating dish is a piece of laboratory glassware used for the evaporation of solutions and supernatant liquids, and sometimes to their melting point. Evaporating dishes are used to evaporate excess solvents, most commonly water, to produce a concentrated solution or a solid precipitate of the dissolved substance. Most of the evaporating dishes are made of porcelain or borosilicate glass. Petri dish. In chemistry, due to their large open surface, Petri dishes are effective containers to evaporate solvents and dry out precipitates, either at room temperature or in ovens and desiccators. Microscope. A microscope is a laboratory instrument used to examine objects that are too small to be seen by the naked eye. A microscope slide is a thin flat piece of glass, typically 75 by 26 mm and about 1 mm thick, used to hold objects for examination under a microscope. Typically, the object is mounted, secured, on the slide, and then both are inserted together in the microscope for viewing. Microscope slides are often used together with a cover slip or cover glass, a smaller and thinner sheet of glass that is placed over the specimen. Ring stand is used to hold or clamp laboratory glassware and other equipment to prevent them from falling or breaking. Utility clamp is used to secure glassware to a ring stand. Ring clamp is used with a ring stand to hold glassware, such as a beaker or a funnel. Bunsen burner is frequently used as a heat source in the absence of flammable materials. Balance is used for measuring mass. Smelting pot, crucible, is used for holding chemicals during heating to very high temperatures. Crucible tongs are used to hold crucibles. Forceps are used to pick up or hold small objects. Wash bottle is used to rinse pieces of glassware and to add small quantities of water. Mortar and pestle are used to crush and grind materials. Personal protective equipment. Chemical laboratories can be hazardous if the rules are not followed. Working in a chemical laboratory, a specialist may handle materials which are carcinogenic, poisonous, flammable, or explosive. Some of these materials and equipment may also cause severe burns, cuts, or bruises if handled improperly or carelessly. Most accidents that occur in the chemical laboratory are a result of carelessness, impatience, improper or unauthorized experimentation, and disregard for safety rules or proper operating procedures. In order to minimize the chances of an accident in the laboratory, certain rules and regulations must be obeyed at all times when working in a chemical laboratory. The role of personal protective equipment. Personal protective equipment is one of the principal ways of protecting from harm when working in the laboratory. Personal protective equipment is used to eliminate or minimize exposure to some hazards encountered when working in the chemical laboratory. Personal protective equipment includes items designed to protect specific areas of the body, such as eyes or hands. Each piece of personal protective equipment has a name and a purpose. Respiratory protection. Respirator. Respirators serve to protect the user from breathing in contaminants in the air, thus preserving the health of one's respiratory tract. There are two main types of respirators. One type of respirators functions by filtering out chemicals and gases, or airborne particles, from the air breathed by the user. The filtration may be either passive or active, powered. Gas mask and particulate respirator are examples of this type of respirator. A second type of respirators protects users by providing clean, respirable air from another source. This type includes airline respirator and self-contained breathing apparatus. In work environments, respirators are relied upon when adequate ventilation is not available or other engineering control systems are not feasible or inadequate. Skin protection. Chemical agents can come into contact with the skin through direct contact with contaminated surfaces, deposition of aerosols, or splashes. Physical agents such as extreme temperatures and ultraviolet or solar radiation can be damaging to the skin over prolonged exposure. Mechanical injuries occur in the form of friction, pressure, abrasions, lacerations and contusions. Any piece of personal protective equipment that acts as a barrier between the skin and the agent of exposure can be considered skin protection. Because much work is done with the hands, gloves are an essential item in providing skin protection. Some examples of gloves commonly used as personal protective equipment include rubber gloves, cut-resistant gloves, heat-resistant gloves. Lab coat is worn to protect against potential splashes of chemicals. Face shield serves to protect the face from potential impact hazards or chemical splashes. Eye protection. Safety glasses or spectacles. Safety glasses or spectacles are the common items of the personal protective equipment used to protect eyes. To meet most national standards, spectacles must include side shields to reduce the ability of debris to get behind the lenses from the side. Goggles. Goggles are forms of protective eyewear that enclose the eye area in order to prevent particulates, infectious fluids, or chemicals from striking the eyes. Hearing protection. A hearing protection device is a protection device worn in or over the ears while exposed to hazardous noise to help prevent noise-induced hearing loss. Hearing protection devices reduce—not eliminate—the level of the noise entering the ear. There are many different types of hearing protection devices available for use, including earmuffs and earplugs. Revision. What glassware and equipment are used in a chemical laboratory? What glassware and equipment do you use in your academic and scientific work, and for what purposes? Explain why following the safety rules is crucial in a chemical laboratory. What personal protective equipment is used for respiratory protection? What personal protective equipment is used for skin protection? What personal protective equipment is used for eye protection? What personal protective equipment is used for hearing protection? What personal protective equipment do you use in your academic and scientific work, and for what purposes?